And apologies, good afternoon, I mean.
Good afternoon, Simon.
What time is it now, Simon, in your area?
7 a.m.
Oh, you're early riser again.
As usual, Lim, you know me. And apologies, good afternoon. And apologies.
Hi, good afternoon, everybody, and good morning, Simon. I'd like to welcome all of you to the launch of our fluorine-free foam system, or what the industry might term as SFFF, and Simon will explain a bit more. So, without further ado, I'd like to ask that you kindly mute your microphones. All right. If you need to ask questions, you can use the chat function, or wait to the end of Simon's presentation. Then we'll open up to the floor for questions. Right? Then you can unmute and ask. However, please take note that there might be some challenges with the audio in the country where you're at. So if you can, I would strongly encourage everybody to use the chat function. So without further ado, I'd like to hand over the floor to Simon.
Okay, thank you, Ray. Good afternoon, everybody, again. Thank you for joining us today and giving up some of your workday time to listen to what we've got to explain and announce in terms of SFFF fluorine-free foam systems. My name's Simon Barrett. I'm responsible for the foam product line within Viking. So I'm heavily involved with product development, R&D, certification work, marketing, documentation, and obviously product launches. This is the best part of my job, when I get to explain to customers, to end users, to colleagues, what we've been working on and what we believe is very interesting for the market. So in terms of agenda, these are the items I want to cover today. I've got a very quick company introduction related mainly to foam, not the whole product line, just to give you some background. We're then going to look into the topic of SFFF, synthetic fluorine-free foam systems. We're going to look at approvals. That's a topic that's coming up a lot in this new world of SFFF. Then we'll look at the product line itself, further support, documentation and tools that we have coming very soon to support you. And then also some design considerations and frequently asked questions to finish off with. So these are just regular questions and problems that we see occurring. So company introduction. Viking's part of the Minimax Viking Global Fire Protection Group. We're over 1.7 billion in turnover, over 10,000 employees across manufacturing, distribution and contracting. We're pretty much represented on all continents and in many countries, both with our own locations or with strategic distributor partners. I think some of those are on the call today, of course. Something very important to the company is our in-house development, our R&D, to keep coming up with innovative new products that can save time, money, and make you competitive against your competition. So looking at our R&D capabilities in foam, this is something that we've expanded a lot over the past, particularly 10 years. For those of you knowing Viking for a long time, you'll know that previously we used to work with other partners, such as National Foam in the past, 3M before that. But around 10 years ago, we decided to bring more product development and manufacturing in-house. So now we've got 2 facilities in the US, at our traditional home in Hastings. That's where we typically do our C6, older foam type concentrates. That work is becoming less and less, as I will explain more later in the presentation. You've just, for those of you that joined us earlier, you've just seen some video footage of our new facility in Caledonia on training. Well, that's not only training, we do have a large R&D facility there as well. And in that facility, we've got about 350 square meters of of area dedicated to foam. Obviously, when we're spraying foam around and testing foam, it takes up quite a bit of space, and it's not really an area that we can use for other development. So I'm very happy that the company invested in that space. We don't have fires there. Running fires is pretty difficult and expensive, and you need proper test facilities for that. But in terms of testing our products, foam qualities, discharge characteristics, proportioning of different technologies, that's all something that we can do in that facility in Caledonia. In terms of fire testing, we do have a fire research hall in Bad Oldesloe in Germany. That's in the Minimax headquarters. So that's where we're able to do a lot of sprinkler testing, foam sprinkler testing particularly. And then we've got our manufacturing facility in Italy, which has R&D capabilities, mainly related to monitors and electric monitors. So between all these different facilities, we've got the capability to cover most research and development that we need. And that's very important because the SFFF era, I'm beginning to call it, we're having to learn a lot of new things. AFFF foams were developed in around the 1950s, so it was very well known, very old, very established technology, let's say. As we move to SFFF foams, we see the need to do a lot more research and development because the product is not behaving the same as the old types of foams. I'll explain a little bit more about that later. So just some background as well that will make more sense when we go through the product line later. As I mentioned, we have a manufacturing subsidiary in Italy. That's 100% owned by Viking. It has been for over 25 years now. And that facility is under its original name of KCA, but effectively they are Viking's manufacturing division for foam products. So that's where the majority of our product line is manufactured. It's a very large producer of bladder tanks. It must be amongst the largest in the world based on our sales research. We've got around 30 employees there, and half of those dedicated to fabrication, the other half dedicated to obviously management, technical support, drawing, and project management of projects. And currently it's the only European-based manufacturer of FM and UL foam equipment. So certainly from a European point of view, we have lots of advantages in terms of lead time. And then we've got a company called PhoneTech. So although we manufacture, I would say 95% of our own product line in terms of hardware, the phone concentrate itself is not manufactured within the Viking Minimax group. We have a strategic partnership with a company called PhoneTech in Sweden. That company has been established over 20 years. It's an independent company, which is very attractive to us because there's no conflicts of interest in terms of our competition. And it's also a company that is very dynamic and quick to make decisions, and together we run a lot of joint R&D projects. So when you see our approvals, you'll see there's a mixture of Viking or KCA and PhoneTech approvals. So this is just to explain the background to those other company names that you might see in this presentation. Something else we've done over the past 10, well, probably 12 years now, to be honest, since 2009, was really invest in approvals in our quality systems, in the quality of our products, in our manufacturing. Obviously that takes investment, but we believe, well, we believed at the time that was the right thing to do. It's something that end users require, it's something that insurers require, consultants, from time to time our customers require. But it's certainly been a lot of hard work, but now we're very well placed in terms of international and local approvals on the phone product line. Here's just a general overview of the type of hardware products that we're talking about. Some of those we're going to come back today in relation to SFFF. So now a little bit of background to what we call SFFF, so synthetic fluorine-free foam. So why is this an issue now? Well, I've already alluded to older or previous technology of foam concentrates. So typically they were AFFFs, AFFF alcohol resistant, ARs, and they had as part of the performance, as part of the chemical composition, they had chemicals or substances known as PFAS inside them. That product enhanced the performance of the foam. Firefighting foam was developed around the 50s by the military to protect things like ships, aircraft carriers. That was one of the initial reasons for developing foam, and the use of PFASs inside the foam enhances the performance greatly. This isn't a chemistry lesson today, so I'm not going to explain why, but we're starting to see a lot of mainstream references to PFAS. So not just within our industry. There's been Hollywood films on the subject. It's finding its way onto talk shows. I saw one in the US last week where it was on a mainstream talk show speaking about PFASs. And so these have been used not just in firefighting foams, but in food packaging, for example. When you get a burger from McDonald's, for example, that shiny kind of packaging that has contained PFASs. Obviously, that industry is trying to change, as ours is. Stain resistance on clothing, so Scotchgard by 3M. That was another product that used PFASs, and it really repelled moisture, water, liquids, giving it a waterproofing and a stain resistance. One of the more high-profile uses has been on non-stick, not non-stock, sorry for the spelling mistake there. So non-stick cooking utensils, like frying pans, that's contained PFAS. And then it's also used in paints and cleaning products, and obviously firefighting foams. So references like PFOA and PFOS, they're the ones that have been most extensively studied, going back to really the early 2000s when things started to change a lot. 3M stopped producing and using PFOS in their products. That's when 3M as a company pulled out of the firefighting foam market. I think it was 2001, which was a big surprise because they were effectively the market leader. They had a product that was very high performing compared to its competition, and that was related to the PFOS that it used, and it was only 3M that used PFOS in its products. Well, now what scientists know is that these PFAS chemicals, they're harmful to the environment because basically they don't break down, they don't biodegrade over time. They can also bioaccumulate, which increases the problem. And there's evidence of exposure can lead to adverse human effects. So cancers have been referenced and things like that. Obviously, for aquatic life, it's not good either. So the if you like, the summary to why we're talking about SFFFs is our current technology has been found not to be good for the environment, and there's a general need, desire, and trend to phase out the use of PFASs in foam concentrate. So during the period of kind of 2000 to 2006, the PFAS product was phased out and then led to an outright ban. So by ban, I mean in Europe, in the US, in any countries that have implemented a ban in that country. I'm not so familiar with all the different countries in Asia, but I am aware that Singapore is one of the more progressive countries, let's say. But in terms of regulations that we see coming into law, this is more, I think, high profile in the US and Europe at this moment in time. So PFOSs were banned and then phased out, and by 2010 in Europe, even if you still had that product in a storage tank, the end user was under obligation to remove that product, replace it with an alternative non-PFOS product, and obviously dispose of the PFOS in a responsible way, which normally means high temperature incineration. We then turned our attention to PFOA. That's also referred to as C8. And there was an EPA stewardship program implemented in 2005, where the producers of these fluorinated surfactants all voluntarily agreed to phase out the use of PFOA C8. That's when we started moving to a different PFAS chemical called C6. And over the period of kind of 2009 to 2014, that's when foam manufacturers transitioned from C8 to C6. And that period was when we had to redo all our approvals, because obviously the chemistry of the foam was different. Well, jumping forward to 2021, what we know now is that stewardship program, although a positive step, it wasn't really enough, because even C6 PFASs are still accumulating in the environment, and they're still part of that PFAS family, although not nearly as harmful as the PFOA and PFOS. So in 2021, what we're seeing is a trend that the C6 era of foam concentrates is probably going to be quite short-lived. Okay, so in Europe, as mentioned, PFOS has been banned since 2006. It's only now that PFOA, there was a European law brought in last year that means progressively until 2025 there will be greater restrictions on the use of foams containing PFOA. By July 2025, their use will be banned, and they will need to be removed from systems. So typically, a C8 foam is something that was sold and installed prior to, let's say, 2014. And it's only now in Europe that we're looking at proposals to restrict the use of all PFASs. This isn't just in the firefighting foam industry, it's in all industries. But one of the issues with the firefighting foam industry, although it uses a relatively small amount of the global PFAS, there's a very high chance that PFAS will be released into the environment when there's a fire, when there's training, or when there's an accidental discharge of a foam system. So firefighting foams are particularly looked at for that reason. As a counter example, when you look at a non-stick frying pan, although there's PFAS inside that, the likelihood of that PFAS being released is very minute. It's unlikely to happen. So the outright ban on all PFASs is going through consultation at the moment. We expect that will be implemented in 2022, and that will result within an increase in restriction and then an outright ban in 5 to 8 years. That's my interpretation of what's happening at the moment. Again, I tried to make these slides very simple and summarizing, and not explain hundreds and thousands of pages of chemical reports and legislation proposals that are behind. The USA is a very interesting one because the situation in the US has changed very quickly over the past few years. What we see is increasingly restrictive laws state by state, and that really started in around 2018. So first it restricts the use of firefighting foams for training, and then that goes all the way through to ultimately the removal of PFAS containing foams in systems in the future. So at the moment in the US, I would say we're at a stage where there's very few projects now happening with PFAS foams. So that's the standard AFFFs, the standard alcohol-resistant AFFFs. And like I say, the situation has moved very quickly in the US. Things tend to happen very slowly in Europe because there's so many different countries and member states, each with their own vested interests. So it's very difficult to get, a consensus. But in the US, it's moved very quickly. And it's moved that quickly that actually the industry, so our industry, the foam producers, the foam product manufacturers, the design regulators, so NFPA, we haven't been able to move quickly enough with the demand. And that's why we've got quite a lot of confusion at the moment, whilst the industry catches up with this demand to transition to SFFFs. As well, looking from afar, we've seen that particularly in Australia, they've been very progressive over the past, I would say 5 to 10 years. They've had more of a smooth transition, I think, to SFFF foams. And they've done that, generally speaking, without the background of testing approvals being in place. But at least now we've got these products coming through, so they will be able to get back to designs and installations with approved and tested products. So some key summaries, the main important points for me is to remember that the demand for SFFs is driven by regulation and environmental concerns. It's not because the industry has found a clever new way to improve performance. Part of the problem is the performance is not the same. It is generally inferior, but I must stress that SFFF foams do work. So there's a lot of discussion to say that they don't work. Others say they do work. We can confirm they do work, but the performance is different. So we just need to understand what the difference is in performance. So yeah, environmentally driven, not because it's cheaper, not because it's easier chemistry, not because it's better for logistics or manufacturing. It's the environmental concerns. And speaking of which, Viking's position is that no firefighting foams are environmentally friendly. Even SFFs, they contain obviously other types of surfactants, which are man-made chemicals, and they do have an effect on the environment. They still have toxicity levels, but the important thing about SFFF foams is they do biodegrade 100%. So they're not long-term persistent in the environment. They only have a short-term effect on the environment. So from my point of view, I don't believe we can consider them environmentally friendly. So one of the common questions, and we'll come on to it later, is can we discharge this foam to the environment? Well, there will be an effect, and it's important to understand that effect. As mentioned, the new generation of fluorine-free foams, or SFFs, they contain no PFAS, which is the product that's considered or is persistent in the environment. So SFFF, synthetic fluorine-free foam, is the NFPA term for fluorine-free foams. The term has also been adopted by FM, and UL are in the process of adopting the term SFFF. So already done with NFPA 11, which was released earlier this year. So you'll find the definition in there. Also with FM. There are other references in the industry. So some manufacturers call it F3, others call it non-fluorinated. But my opinion is that in time they will be known as SFFs, because obviously the large organisation affecting the foam, NFPA, FMUL, have adopted that term. So speaking about FMUL and the importance of approvals. So as a background, approvals are important to verify the suitability of concentrate and hardware working together. As I mentioned, SFFs work, but their performance is different to what we're used to in the past. So we've seen, and I mentioned that PFOS, the 3M product, Light Water was the brand name of it. That was a very high performance product, but we retrospectively understood that some of the chemicals in there were not very good to the environment at all. We then focused on PFOA based foams, or C8, and the performance went down a little bit. We then moved to a cleaner C6 type of product, and again the performance went down a little and changed. Now we're moving to SFFs, and again the like-for-like performance, generally speaking, has reduced. What that means is the safety factor that we had in those design standards, which have remained the same at the moment in terms of minimum densities, it means that step by step we've removed the safety factors. So what we're seeing is that it's more important than ever before to have some form of verification. So I'm speaking particularly about end users, insurers, fire consultants, authorities having jurisdiction. You don't have that comfort zone that we had in the past in terms of the foam's performance. And what we've seen over the past couple of years is that end users are very much educated and understanding design standards and approvals. So I've seen a lot more end user interaction on the subject of SFFF than ever before. We've always believed it's been important to have an holistic approach. That means foam concentrate and hardware working together to give the right performance. It's not a case of taking a UL listed foam from one company and a UL listed device from another and just putting them together. That is not a system approach. And it could work, but it might not work. The important point is you don't know as somebody making that decision. When you use products in line with their approvals, then you've got that higher level of confidence that the system you specify, design, install is going to work in a fire condition. And when we look at a foam system, generally we're talking about a foam concentrate, a proportioning method. That could be with a ratio controller and a bladder tank. It could be with a foam pump. It could be with a water-driven turbine pump. And then thirdly, it's the type of discharge device. The discharge device tested with the foam is very important, because what we've done moving to SFFF is taken away something called film formation. And this film formation was very powerful for preventing vapors escaping from flammable liquid fires, for example. So now all the chemistry, all the mechanism for extinguishing a fire and then preventing vapor release and keeping it stable afterwards, it's all about that foam blanket. And the foam blanket, the depth of foam, the bubble structure, is a combination of the foam concentrate and the discharge device. So this is not just my opinion or Viking's opinion. This is independent research by the NFPA commissioned a report a couple of years ago, and this was also confirmed that the discharge device does have a big difference. What I'm going to do very quickly, I'm not going to go into detail, but I do get a lot of questions related to approvals, even within our own organization, and it's very apparent to me that we don't always know where to look for approved products. So I'm quickly going to go on to the FM approval guide. This is free of charge. You just need to register. And then here, normally we're in fire protection, and this is where you'll find all the FM approved products. So you've got sprinklers, hydrants, you'll have check valves, deluge valves in there. We live in fixed extinguishing systems. So you've got clean agent, dry chemicals, and then we've got foam extinguishing systems here. If we move to low expansion, then this is where you'll find all the different manufacturers with different products. And what FM did around 18 months ago, they changed the way they list products to focus on the individual foam product type. And then when you go into that foam product type, it will list all the types of hardware that's available with that foam product type. So we've got proportioners, given a size, a range of use, sprinklers, and things like that. So this is where you can see the detail of what type of piece of hardware is approved with which foam concentrate. And then with UL, which is the other main internationally recognized organization. Obviously, FM are an insurance company, which are approving products for use in their insured system. UL are more of a third-party testing organization. And what we've got here is, for example, I've used PhoneTech. Again, it lists all their phone types, and then you see the different devices listed below that. So it's quite complicated to understand, but this is where you're going to understand and find which type of foam is approved with which type of equipment. Unfortunately, at the moment, UL do not. They do not. They've changed it. So resistant synthetic. They don't make it clear that these products are SFFF, whereas in the FM approval guide, they clearly state that it's an SFFF type. UL are actually making a lot of changes to the UL 162 standard at the moment, and making these products more clearly identified is one of the changes we hope that they make. So that's just a little bit of background on why product approvals are important. So moving to, we've gone through why we're changing. We've gone through some things to look for when you're specifying products to change to. Now I want to speak a little bit about what we've been busy with over the past really 4 or 5 years. This has been in development. We've launched a phase 1 program of SFFF products. Ideally, we would have waited until phase 2 because that will give us a much more comprehensive product line, but that's probably going to be towards the middle of 2022. And actually, the demand from insurers, from end users, meant that we needed to release what we had already. So it's not a complete product line, but it does address certain applications and give certain solutions, particularly in sprinkler systems, as we'll see later. So the last bit of chemistry. Giving this presentation over the past few weeks, I was asked to add this slide in to better explain why we have 2 different types of SFFF foam concentrate. So back to a chemistry lesson. When we look at using foam concentrate, it's normally with Class B ignitable fuels. So we're looking at liquid fires. Yes, we do have foam applications on Class A, forest fires, for example, in logistics, plastic storage bin. But I would say 90-95% of systems that are installed for the protection against or with Class B ignitable liquids. And within that group of ignitable liquids, we have 2 different types. And they're designated depending on their ability to mix with water. Okay, so firstly we have a non-miscible liquid, which is a ignitable liquid that does not mix with water. So here we've got an example, just olive oil in water, and you can see that the 2 different liquids just don't mix. They separate. You can shake that up, it will look like it's mixed, but then the oil will form back into itself, and at no point will any of that oil absorb any of the water. So this is what we call non-miscible. We also refer to it as hydrocarbon. So typically these non-miscible fuels are derived from fossil fuels. So oil, diesel, kerosene, jet fuel, those type of chemicals. And then we have the miscible type of chemicals. Here I've used obviously a cocktail. Alcohol has a high ethanol content, which is a polar solvent. So we know that when we mix vodka with tonic, for example, it mixes very easily. Yes, we give it a stir, but even just pouring the two products together, they will mix easily. That's what we call a miscible product, or another term is polar solvent. So these are chemicals that do mix with water. So the reason it's important to understand the difference between the two is the foam solution. So we're going to take our foam concentrate. Normally we're going to mix it at 3% with water. That's the more common mixing percentage. And then we've got a 100% solution. That solution then travels to our discharge device, and it's discharged through a monitor, through a sprinkler, through a foam chamber, different types of device, and that will create some form of foam, what we call finished foam. So foam solution up to the discharge device, and then finished foam is discharged on the fire. So that foam blanket is 97% water. So what happens when it's discharged onto a hydrocarbon type of fire? The specific gravity of that fuel that we're protecting is greater than the foam solution that we've applied to it. So what happens is that foam blanket rests on the top of the liquid. So it stops oxygen getting to the fire. It stops vapors escaping. And that's where we get the extinguishment effect, but also the post-fire protection, stopping those vapors escaping, because that bubble structure will stay there. Even though it's 97% water, it's not mixing with that fuel. With a miscible liquid, we have a problem, because when we discharge a foam onto that fire, because it's 97 parts water, it's going to mix with the ethanol that's on fire, for example, and the foam will effectively sink and get destroyed. So we lose the ability to extinguish and vapor suppress the fire. So what we need to do is we need to add extra chemicals. And normally what we do is add a gum polymer, basically a rubber, a liquefied gum, which when discharged as a foam solution, it breaks down and forms a polymeric layer on the surface of the liquid. And what happens is that polymeric layer does not mix with the ethanol. So it forms a barrier, a level, a skin. It's like a skin of, I don't know, custard, gravy, a kind of sauce. When it goes cold, that has a skin on the surface, and that's the type of barrier that it looks like. And what that means is that the new foam coming through can then rest on that barrier, and it doesn't mix with the ethanol, for example. And that's what we would call an alcohol-resistant foam concentrate. So when we look at the C6 foams, we have a standard AFFF that we only use with hydrocarbons, and then we have an AFFF alcohol resistant, which can be used with polar solvents. And that's the difference between the two. And that's why we need two different foam concentrates. Some end users standardize on an alcohol resistant because that will cover polar solvent and hydrocarbon. The downside to that is typically an alcohol resistant foam is twice the price of a non-alcohol resistant foam. So that comes down to a commercial decision mainly. So moving on to our first new foam concentrate, we've got the Viking ARK, ARK. ARK doesn't mean anything. It doesn't stand for anything in the background. The owner of Foamtech is Norwegian. It means something to him in Norwegian, but it doesn't mean anything to us. So the brand name is, or the product designation is ARK. That's available as a Viking brand, and it's also available as a Foamtech brand. So remember earlier I mentioned the partnership we have with Foamtech, and basically we cross-list and private label their foams in our name for commercial reasons, for distribution reasons. So these two products are the same, just branded differently. This is an alcohol-resistant, fluorine-free foam concentrate, generally designed to be used at 3%. So all our approvals and testing is done at 3% proportioning, and it can work on hydrocarbon and polar solvent fuel fires. We've got international approvals with UL on foam chambers at the moment. We're going to look at that in a bit more detail. This product is what we call viscous, so it does have a higher viscosity. But it can still be used with bladder tanks. It can be used with foam pumps. It can be used with water turbine type devices. It can be used with adductors as well. Obviously, though, being a higher viscosity, its performance must be known with those products. So again, testing in the background is very important, and that's where again you would look to a UL listing or an FM approval to verify that this product or this foam can be used with a certain proportion in technology. So this is the first fluorine-free concentrate to have been tested and approved by FM on polar solvent fuels with non-aspirated sprinklers. So this is something very exciting for us. It's something we've worked on for a long time. It's been our priority with Viking and Foamtech. Viking, at the end of the day, is a sprinkler manufacturer. There is a huge market for foam-assisted sprinkler systems. I think we tend to, certainly in my opinion, we tend to focus on oil and gas refining because they tend to be much bigger in scale, have large foam monitors and things like that. But there's lots of storage facilities, there's lots of manufacturing facilities for different chemicals. So for us, sprinklers was always our number one priority. I mentioned earlier that fluorine-free foams work, but they can be different. We shouldn't make assumptions. And one of the areas where we're not so strong with this product is where we use salt water to mix with the foam. So typically this is not going to be a problem for a warehouse, for a factory. Salt water is generally used obviously in marine applications, so oil rigs, ships, but it could also be used on coastal power plants or desalination plants and things like that. So what we would need to do with this product is we would need to mix it at 6%, which effectively makes it a little bit stronger because the salt water takes away performance. So again, when you look in the detail of the FM and UL approval, it will tell you if that product is approved for use with salt water or not. Or if it is approved for use with salt water, is there any difference in proportioning method, for example? Secondly, we've got the USP product. Now this is, as you can see, only mentioned Foamtech Enviro USP. This is because we haven't yet implemented the Viking branding for this product. It will be done early next year. So that will then become Viking USP and Foamtech Enviro USP. This product is for hydrocarbon fuel fires only. It can be used between 2 and 3%, but as Viking and fixed systems, we've only tested at, well, we've tested at 2 and 3, and we decided that we would use 3% as our standard. And that's again with a freshwater supply. This product has quite a few more approvals. The USP, we actually got the UL listing on it about 4 years ago. So ARC is totally new, but USP has been around for some time. So we do have some more approvals on that. So there's the European approval as well. We've got the Maritime IMO standard approval, and then ICAO, which is aviation firefighting emergency response, and that's a level B. So this is a very good all-round product, for example, in airports, having all those different approvals, because we're only looking at hydrocarbon risks in airport fueling. We've got approvals for use with handline adductors, monitors, sprinklers. We'll look at that in more detail later. And again, this product is also not as well performing when we look at saltwater applications. So as a summary, USP is a fluorine-free alternative to AFFF, 3% SC6, which is our FMUL approved product. And then the ARC is the alternative to the alcohol-resistant AFFF 3x3. Note that I refer to them as alternatives. They're not drop-in replacements. When we look at using SFFFs, either to transition an existing system or using a new system, there's lots of variables we need to look at. So water supply, as we've already seen, is it fresh? Is it salt water? The fuel type, is it acetone that we're protecting? Is it ethanol? Some are easier to extinguish than others. That will have an effect on the density that we need to apply to tackle those fires. The discharge device is very important. Proportioning method. New or retrofit systems will have much more of an impact to look at as opposed to a new system installation. I cover that in a bit more detail in the frequently asked questions later. And it's just a summary. The ARC is offered in both of our brands. The USP only in Foam Tech with KCA hardware, but that will be resolved early next year. So I think for any planning, this won't be an issue. As mentioned earlier, the situation's not ideal, but we had certain insurers knowing that we'd already done all this testing, and they wanted us to release it into the market. So we've done that. Speaking about markets, I want to be very clear as well. There's two different type of markets when we look at foam concentrate. First is emergency response, and this is basically anything that any application where foam is applied by a firefighter or a manual application. So we're looking at forest fires, we're looking at airport emergency response, so plane crashes, local municipal fire brigades, they all have a stock of foam on their fire trucks. So that's what we would call the emergency response market. Typically, Viking is not in that market, and I'm assuming that most of the people listening today would not be in that market either, because we belong more to what we call the systems market, the fixed systems market. So this is where we're designing those systems to recognize standards, to give a level of safety, because those systems are normally automatic. They've got to operate and tackle the fire when no human intervention is around. So it's a fixed system that does the work. not a firefighter with a hose. So for that reason, we need to be very strict and precise with what we design and install and test, because if there's nobody there to compensate for a fire increasing or getting out of hand, we need to make sure that that system is capable of tackling that fire. Whereas with a firefighter, they can just add a firefighter, they can turn up the flow rate, they can increase the percentage of the foam concentrate. They've got several things they can do to adapt in a fire. So we're in the fixed market system equipment, and the first part of our moving to our product line now, the first part of our product line is the foam storage, let's say. So with the ARC foam concentrate, we have FM approval with our standard line of vertical and horizontal bladder tanks. Again, we've got for sure the largest range of options on bladder tanks. Sometimes this is bad news when you need to decide what you want, but we have different designs. So we've got to the European code with FMUL approval. We can build in accordance with ASME, or we can verify with U-stamp with ASME. Obviously, all those three options have different price impacts, but all of them have FM and UL approval, for example. We now have a range of stainless steel tanks as well. So if you've got aggressive environments where perhaps you're using salt water in the supply, which will corrode carbon steel quicker than fresh water, or maybe it's the external environment, we do offer stainless steel tanks now. We also offer 12 or 16 bar rated tanks with all those approvals. 16 bar rated tanks we normally see where in logistics where there's large pumps and churn pressures go above 12 bar. We've also got a UL listing and FM approval for the USP. Due to manufacturing reasons, that won't be available on the market again until early next year. But you see that the product's already approved, tested. So if you're working on projects 3, 6, 9 months up the line, then this is a product application you can consider. Ratio controllers we don't do so well with at the moment. So as you can see, we only have 4, 6, and 8 inch with the USP at UL, and then we have the 8 inch ratio controller with FM on the USP. Currently, we have no ARC ratio controllers. The reason for that mainly is, you'll see on the next slide, we focused on wide range proportioners. However, we are testing we're testing at the moment actually further sizes of ratio controller with the ARC foam concentrate. So that was just a question of priorities, what we did first. And that product is available in both groove connections and flange connections as well. So moving on to the wide range proportioner, this was our focus to do first because we wanted to focus on sprinkler systems. And because both the USP and ARC are what we call higher viscosity, they're around 2,500 MPa. So it's not low viscosity, but it's not high viscosity. There are a number of fluorine-free foams on the market that are even higher. In fact, the viscosity of that foam, so by viscosity I mean the thickness of it, how liquid it is, let's say, it's actually comparable to our fluorinated ARC 3x3S product. So viscosity is very important to understand as part of the performance of the system, and that's why we've put this product through FM for use in sprinkler systems. We don't have UL because we've taken the decision not to put it through UL at this time. That's purely from a cost and return point of view. When we use foam pumps or bladder tank pressure regulating systems, we use what we call an inline balance pressure proportioner. So this is the, you can see the ratio controller here, but on the inlet, we've got a balancing valve. So this is going to be used typically with a foam pump, like you'll see on the next page. So we supply our foam concentrate at a higher pressure than what the water supply is at. And then this balancing valve is sensing the water pressure, sensing the foam pressure, and regulating a fixed 3% allowance of foam into the ratio controller. Again, not so many approvals here, but we are working on extending that for the ARK at the moment. This is the foam pump that I mentioned. So we've got the foam pump here. This is part of a foam pumping skid, and this would be the no, number 3 is no, it's this one. So this would be our foam outlet going to the ILBP proportioning device. Typically, we see this type of proportioning on large infrastructure projects like a airport or a refinery, and it's where you've got multiple different risks that you want to protect with one foam supply, instead of having a dedicated foam supply at each risk. So that's what I mean, larger infrastructure projects, because the commercial situation means that you can spend more on your central pumping, and it's less than putting individual smaller systems in around your site. But again, this the pump that we use, it's from a company called Firelion. So they have FM and UL approvals for their product up to a certain viscosity. But what we've done as well is we've gone beyond what we need to do for the approval, because we've specifically tested with USP and ARC to understand how those particular foams work with these pump. And we found out some things, and I'm not going to divulge that because it cost us money to find out things. But again, it's important when considering SFFFs that you're asking the manufacturer, can you verify that performance? Have you tested that? Have you got a certificate, or have you got internal test data? Moving on to the sprinklers, a bit of a mixture of green yeses and red no's there. I would say that we're pretty strong on both foams with K80s and K161s. Not so strong on K115s. So that is something that we are fire testing actually in the next quarter. That's all booked, scheduled, pre-tested. So again, that grid will be updated early next year. Some of our test programs, let's say, have been COVID affected, both in terms of laboratory availability, witness testing, because obviously engineers have not been able to travel to witness tests. So that's very much slowed down the program, which is why we're implementing it now in 2 phases. But again, the important thing to remember is that ARK is a polar solvent product, and these yeses represent the only fluorine-free foam on the market approved with sprinklers, with both FM or UL. So it's a very challenging thing to achieve, but we've done it. Okay, so looking at bund protection, we would typically use a foam maker, for example. So this product, you run the foam solution in here. It passes through these Venturi air inlets and draws air into the device, and that's what expands the foam and gives us a better foam quality. So at the moment, we have a approval for a 2.5 inch on the USP foam with both FM and UL. With the ARC product, we needed to run further fire tests, which we've now done. So again, that's another approval that we will see early next year, with additional sizes as well. And what we always aim to do is we don't like to have a fixed point approval. What I mean by that is when you go into the UL listing, like I demonstrated earlier, the manufacturer's listing will show a discharge pressure. Now, the cheap way of getting an approval is just running it at one pressure. But for a designer, if you can only discharge at 55 psi to be in compliance with the approval, that's not very flexible for you. So in our opinion, and most mainstream companies do this, in our opinion, we should give a range. So for example, from 40 psi to 100 psi. What that means is we've verified that across that range, the foam that we produce will extinguish a fire. So you can imagine the more tests we do, the more expensive it is. So that's another thing to look at. Has that manufacturer only got a fixed point approval, or have they got a range? Because trust me, if you want to go low in pressure, that's when we struggle to get good foam. So if there's only a fixed point approval for 55, you want to use it at 40 psi, you're taking a risk without getting correct verification from the manufacturer. Foam chambers used on large atmospheric storage tanks. Again, we've only got 2.5 inch and 3 inch. At the moment, we only have fixed points for the USP. We are extending that range. So I'm slightly hypocritical, but again, we've had to launch before we really wanted to, and we're extending that range of discharge pressures at the moment. With FM, we don't pursue an FM approval because FM typically do not protect these types of object. Fixed and manual oscillating monitors. We have an approval with UL on the USP. No plans at the moment with FM or to test the ARK with UL. I think this is something we'll look at probably later next year, depending on market demand. You know, if you give us the feedback that you need this is something we can work on and test. I know we've got some customers online involved in aviation projects. So currently we have no, oops, I still haven't corrected. Every time I do this presentation, I notice I haven't changed this to USP. So with USP, which is the hydrocarbon-based foam or protection of hydrocarbons, we've got nothing with FM or UL at the moment, but we're well progressed with something, and there'll be an announcement early next year on that. With ARC, it's not applicable because we don't protect polar solvents with the great nozzle in hangars. The reason this product is important is there's hundreds and hundreds of hangars across the world with great nozzles inside. So for you contractors that are on the webinar today, you may be invited at some point to talk about changing the fluorinated foam to a non-fluorinated foam in the great nozzle system. So we've got that coming very soon. So like mentioned at the beginning of that, it is a bit confusing. It's not perfect. It's not ideal. However, on the flip side, it now gives AHJs and customers and end users certain options with SFFFs. So although we haven't got green yeses everywhere, We do have yeses, for example, with bladder tanks, wide range proportioners, and sprinklers. So from a sprinkler system point of view with alcohol resistant foam, we've got a comprehensive approval, I would say, well, with the exception of the K115 sprinklers, of course. Then when we look at other applications such as alcohol resistant with a foam monitor as the application, then we don't have that at the moment. I'm not going to talk about competition too much, only to say that we have several unique approvals or solutions for you. And as a general product line, we stack up very highly against our competition. Okay, so something else we've worked on a lot over the past 10 years as well is improving our documentation. We're not there yet, and it makes me sad when I say 10 years that we've been trying already, but certainly with any new product that we're coming out with, we're really focusing on giving you the right type of information in the technical data. We love speaking to you guys, but at the same time, we understand you're very busy, and you want documentation where you can find your answers very quickly and not have to wait for us to answer an email or get back to you on a phone call. So in terms of the type of documents we have available, this is actually the product launch presentation that I gave internally, explaining to all our internal people what we've got. So we have a general quick reference guide of foam products. That's more of a commercial brochure type of publication, but it also enables you to look very quickly what type of products we have available in the range. We have what we call product sheets, and then we have what we call technical data pages. So a technical data page is where we give all the information that you need about the product's weight, size, usage conditions, how to install it, how not to install it. We give the approval information, we give spare parts information, things like that. So that technical data page could be 1 page long, or it could be 20 pages long. Normally, they're more kind of 10 to 20 pages long, depending on the product. Now, what we understand is that for those of you who are perhaps making proposals from a contractor to an end user, maybe you don't want to put together a package with 200 pages of technical data. That's probably not very useful for the end user. So what we have is product sheets, and these product sheets are always 1 page, and they give the very basic information about the product without going into to detail. So it tells you what the product is, you can see what it looks like, and it gives the basic approval information. So all these are available for all SFFF products, and actually most products within our foam product line. We also put the FM approval certificate online as well. Our price lists are available online, and they're all updated with SFFF products. Technical data pages I've already mentioned. We have safety data sheets for the foam concentrates. So these are normally required by the environmental people at an end user, particularly now that firefighting foams are more under the microscope. So this will give you the toxicology information about its effect in the environment, for example. So all those are available in Viking's name as well. And then we've got various images, photos, PowerPoint presentations, and this is more internal commercial things. We did produce a YouTube video on our YouTube channel as well, myself and John Otterson from Foam Tech, discussing things like foam qualities, SFFF foams in sprinkler systems and things like that. it's just basically two phone nerds talking for 45 minutes, but that could be of interest for you. In terms of where you find this information, probably you are, as customers of Viking Asia, you're used to using the Viking Corp website. So this is our American sister company's website with all the sprinklers, valves, and core Viking products on there. However, in the US, they only put products on there with FMUL approvals or products that they sell. So it means that there could be products within our range that you're missing because they're not on the US website. So if you use the Viking EMEA website, the layout's slightly different, but this is where you're going to find all the foam products. So we've got quite a good filter here. So for example, if we look at proportioning devices, and we've added a filter for SFFF as well. So if you're specifically looking at SFFF, what we call compatible products, you can select this box as well. And then this brings us up at the wide range proportioner. When we go to show details, this is where you're going to see the product sheets, quick reference guide, and the technical data page as well. So for example, this is the one-page product sheet that's just got all the basic information on there. So that's something you could give to your customer to say, this is what we're proposing for your project. So again, that's the Viking EMEA website there. We've also produced a landing page as part of that website. We're doing this with all our major new approvals now, and the idea of a landing page is that we give interested parties all the basic information they need in a quick, concise way. Obviously, we don't have time to read through lots of things, so this landing page, if you put searches in, it's coming up on Google. What I instruct our internal Viking people to do is send this link directly to any interested companies, because this is just going to give you the basic information. And then what you can do from there is move to our dedicated SFFF document. And this is going to give you, again, an overview on the environment, regulation, changing out of systems, systems approaches, the different types we consider as SFFF concentrates, fluorine-free concentrates. And then we've got this overview table, which over time will become more comprehensive, let's say. But here you can see already what different foam types we have with discharge device and what approvals we have as well. And then we just go on to talk a little bit about non-aspirated sprinklers. So again, that brochure is quite useful to give you some basic information. For the distributors that are on the call today, this is something we would encourage you to distribute to your customers as well. Okay, some other things that we're working on at the moment. What I found giving these presentations is that the overview of the kind of the legal and environmental situation is very useful to people. Also, these frequently asked questions and things you need to consider. So what we've decided to do is move these to dedicated technical bulletin pages, which I'm hoping will be available in the next 1 to 2 months. So instead of going back to presentations or looking deeper, you can just use this technical bulletin from us to give you an overview of the situation. And the other thing is that enables us to adapt and change and update those technical bulletins as the legal situation changes, because that will change a lot and frequently over time. We also want to create some clear on-site processes with relation to transitioning and changing systems. R&D, as I mentioned, we're still very busy. I'm very happy because the next quarter I'm going to spend outside of my office in testing facilities running fire tests. So since the beginning of COVID, this is something that we haven't really done. So at least we can get back in to the testing now. And what's also important to me is ensuring that we get feedback from the market. So normally I like positive feedback, but actually positive feedback isn't useful to me. It's more negative feedback. What applications are we missing? What sizes are we missing? Are we missing fuel groups? What information are we not giving you? So that's always encouraged to be fed back through our Viking colleagues on the ground, because that's the only way we can improve, by listening to what you say. So now I'm just going to go through a few bullet points. These are in no particular order. They're clustered a little bit, but these are the type of questions that we get asked, or that we want to ask you. So if you're considering using SFFF, these are the reasons why that might be. You might be in a country where this is not an issue, this is not a topic. Perhaps this is something totally new for you today. But if somebody's requesting or considering using AFFF, it's normally due to regulation, which would be particularly in the US. It could be end user policy. So, for example, US companies that are multinational, international, and they have a company policy that says we will transition our phone systems globally by this date. I don't think it's any secret. One such company that's done that is DuPont. So they made a commitment that they would transition all their PFAS-based phone systems globally by the end of 2022, I think it is. So even though you might not have a legal requirement in your country to use SFFF, if you have a DuPont facility in your country, then they might be saying, look, we want you to transition our system to fluorine-free. Another reason might be future proofing. So we're particularly seeing this a lot in Europe, where there's no ban on PFAS yet, but we know it's coming. We don't know the actual details, we don't know the actual dates, but if somebody's installing a new system in 2021, and if we can provide the same level of approval performance with an SFFF foam compared to a PFAS-based foam, then why wouldn't we use SFFF now? So there's a certain amount of future proofing that's going on. So these are the discussions that we're generally having with the market at this time. One of the very early questions we need to ask is the application, is the project, is it a new system or is it an existing system? I'm going to come back onto existing later, because there's extra questions that we need to ask there. What design standard are you using? NFPA cycled in 2021, so there was a new NFPA 11 implemented, but what we couldn't do in time is have a comprehensive guidance within the main body of the design standard. So SFFF references have been put in the annex, but they're more for information, for guidance. NFPA 11 went straight into cycle again, and I believe it's planned for a 2023 edition. So that's 3 years earlier than it would normally be released. The reason for that is we know that we need to give more design guidance for for SFFF type foams. So at the moment, yeah, we're going to look at what standard you're using. Is it NFPA? Is it a factory mutual data sheet? Is it an EN standard, for example, or is it a local code? What approvals are required? Like I say, I'll be perfectly honest. I've got a commercial interest to tell you to use approved products. The reason I do that is because we've spent the money, we've invested the money to verify that that product is going to work. And that's why typically an approved product might be more expensive than a non-approved product, because approvals are not cheap to run. But I'm asking what approvals are required because, as I mentioned earlier, end users, insurers are becoming much more knowledgeable on products going into their systems because of this high level issue related to PFAS. So we are seeing a much greater demand for approvals. And obviously our advice, our capability to meet your needs at this moment in time will vary depending on what approval you need. Is it FM, is it UL, or is it something different? So that's something that's going to affect what we can do for you. This one I've added through painful experience. So are the end user and AHJ requirements consistent with each other? Now, this is a real life situation where an end user transitioned an AFFF system to an SFFF system, and they did that based on some internal tests. So it wasn't done guessing, extrapolating. They did external tests with us, with PhoneTech, and they said that internal tests were good enough for them. Well, those internal tests were good enough for them, but when the local fire chief came to sign off the system, they wanted to see a UL or FM approval. And that was a big problem for some time. So even though it was the end user's system, their responsibility, they were happy with the internal tests that we'd done. The fire chief wanted an FM or UL approval. And we've had to do those approvals now. We've had to do those tests and add the approvals before they would sign that system off. So that's something else just to bear in mind. What fuel are we protecting? Is it hydrocarbon? Is it a polar solvent, miscible or non-miscible? If it's a miscible liquid, a polar solvent, which particular type is it? What volume is it stored in? How is it stored? Because again, we can't assume that an approval for acetone is automatically covering all types of polar solvents. We know that there are some polar solvents that are particularly more difficult to protect with SFFF foams compared to fluorinated foams in the past. That's linked to this, you know, what if the equipment supply manufacturer, in this case Viking or PhoneTech, has no approval or test data for that particular fuel? This is one that's coming up a lot actually at the moment with ethanol. So we don't have at the moment approvals with ethanol because we have used IPA, isopropyl alcohol, as our test liquid because we know that's more difficult to test at. But what we then need to do is make an assessment to say that ethanol is a lesser challenge, but still use the density that we have for IPA. Now, if we don't have that information, we don't have the information. Okay, we will not guess. We will not, tell you something that we cannot back up in terms of either small scale laboratory research or fire test research. But if you're an end user or if you're a contractor working for an end user and you've got a large facility to transition, and if they've got a particular sprinkler or a particular nozzle that they use throughout, they don't want to change it. There's a particular fuel and we don't have test data for that. then what we have started doing is end user driven test programs. It's not cheap in terms of a test program. You would be looking at $50,000 to $75,000 per week. If you need a week, it depends on the actual test. But if that means you don't need to remove all the discharge devices already on site, you know exactly what discharge densities you need to work at, which might save you upgrading pumps and tanks, then there is a payback in that. So we are involved in a number of end user driven test programs already. How is it going to be protected? Are you going to use sprinklers, non-aspirated sprinklers without the bulbs in deluge systems? Is it going to be a monitor? Is it going to be a foam maker? So that's important information that we need to give you advice as well. This is a great one. Can the discharged SFFF solution go down the drain? Okay, so our advice is always very ambiguous on this. We pass that on basically to the local authority having jurisdiction, which will be the local environment agency or the local municipality. We do know that in some areas of the world they let foam solution go down the drain, but as I mentioned earlier, even as a solution, so what I mean is it's a volume of liquid that is 3 parts foam concentrate, 97 parts water, so it's very, very diluted, but it still will have toxicity related to it. So unfortunately, all I can say is that it's more likely to be accepted to go down normal sewerage, normal drainage areas, but you won't see us giving a confirmation that it can be done. But what we want to do is provide the right safety data sheets that can be given to people locally that can make that decision on how to dispose of the solution. Now that would be after testing, or if there's an accidental discharge, for example, because if it's been discharged as part of a fire, then you've got your chemical, your ethanol, your acetone, your olive oil, whatever, that you was protecting. So would you put that down the sewer? So I think it's only for testing mainly this question comes up. For those of you involved in actual testing of systems, to verify proportion inaccuracy, we use traditionally a method called conductivity. That involves making up some predetermined samples, taking readings of those samples, and then plotting that on a graph. And then we run the actual system and see how the actual foam solution compares to it. So what I can confirm is, yes, we can use conductivity with SFFF foams. However, when you make those initial samples, you need to mix the water and the foam together. The SFFF, typically SFFF foams, this is not just Foamtex products, they take a lot of stirring, okay? I mean, if you've got a spoon and you're stirring that, you're going to be there for 1-2 hours stirring it, because it's very difficult to get the foam and the water to mix together. In fact, what we use now is basically a hand drill with a spindle and a mixer on it, so we can do it quicker, but it still takes 15-20 minutes to do it that way. So that's my big warning. You know, make sure you mix the predetermined samples. By predetermined samples, I mean you take for example, a 1 and a 3 and a 5% mixture. So you're going to add 1 part foam to 99 parts water, 3 parts foam to 97 parts water, and so on. That's what gives you your baseline. If you don't mix those samples correctly to begin with, your baseline will not be correct. And it will probably mean that when your system proportioning sample comes along, it won't match and the system will fail. And you don't want a system failing, so it's important to mix those samples correctly. Another one, can I fill my system with Premix? I don't know, Ray, but I think I saw an email that maybe we've got some FM colleagues from FM Global on as well. And in FM's data sheet 4-12, they actually recommend the use of Premix. So if you've got a foam system, instead of just filling it with water, this is if it's a closed head sprinkler system, sorry. Instead of just filling with water, they prefer that you fill with Premix. Now, this is a good idea in theory, because it means that you've got foam solution at the sprinkler when the system discharges. The problem with Premix is, and this has always been the problem, after time, it's no longer a Premix. Now, that time could be 2 months, it could be 2 years, it could be 5 years. But you wouldn't know without testing, and corrosion inside the pipe, the water quality, temperature, they will all affect how long that that mixture remains as a premix. What we are seeing with SFFF foams is that that doesn't remain as a premix for very long at all. I've just explained it's very difficult to manually mix the foam and the water together. But when it's in its premix form, we've seen that it even separates after, half a day, as little as that. And FM have now introduced a new test in FM 5130 that basically says if you as a manufacturer will propose and recommend your product for premix, you need to do this additional test. So again, this isn't just something related to our foams. It's an inherent new situation with SFFF. Just going back to this proportioning one as well, what we see is that the mixing of the foam and the water when using proportioners, ratio controllers, is actually very good, because it's a very violent the way the ratio controller works with the increased velocity. When the foam enters the ratio controller, it's doing that at speed and there's a lot of turbulence, and then it travels down the pipe. So we find it mixes actually very well in that case. It's just mixing when we're doing it manually. So I don't want to scare or misinform people about your actual system. That will mix perfectly okay. So if it's an existing site, then we do have some additional challenges. So there's a reference to drop-in replacement. What that means is you've got an existing system, you're just going to empty the storage tank of AFFF and fill it with USP, and you're good to go. I think it's going to be very unlikely that that can ever happen. So in terms of a drop-in replacement, it's going to be very difficult to get that. There's always going to be issues related to proportioning, discharge devices, the approvals, the performance on that particular fuel group. So that's why I mentioned all those points previously, because you're not really going to see a drop-in replacement. You also want to understand what the existing discharge device density is. So if we use sprinklers as an example, if they're using an FMUL approved AFFF alcohol resistant foam, we might have a approval density of 0.3, which is a 12 millimeter discharge density. So your pump, your tank, your pipes have been designed to give a 12 millimeter density. But with that same fuel, if we can't pass during testing at 0.3, 12 millimeter, we might need to move to a 0.4, 16 millimeter. Now that's going to have a major effect on your water supply, your pump, your pipe work, and maybe even the sprinklers themselves. They might need to be changed. So that existing system density is one of the very first questions that we're looking at. And trust me, as a manufacturer doing this testing, the number one priority for us is achieving equivalent performance at the same density. If we need to move to a different percentage, if we need to change some other things, that's much less of a problem than you having to change pumps, tanks, and pipework. And I guess for the contractors on the call, maybe you want that, but certainly our end users and our insurers probably don't want that. So there's a bit of a conflict of interest, but at the end of the day, we need to ask these questions and make that assessment. Like I said, what's the existing pump and water supply capacity? Because even if we need to increase our density, if the capacity is much greater than this particular area we're changing, then perhaps within the existing pump and water supply, we don't need to change. We can increase density without changing the water supply in some situations. What's the current proportioning system? Is it a bladder tank? If it is, you're going to have to, at the minimum, remove the bladder from the bladder tank, because that will have some of the previous foam impregnated into it. You probably need to change the proportioner as well. If it's a foam pump system like we saw earlier, is that foam pump going to work with the new viscosity of foam? Is the suction line sized correctly? The atmospheric storage tank will probably need to be replaced, because that will be cheaper than cleaning the tank, for example. If it's a water-driven pump, such as FireDOS, for example, again, the suction line will probably need recalculating at the very least. The tank will need replacing, but probably the FireDOS unit itself can remain. But there's no, I think what we're learning is each site, each situation is different. What age is the foam concentrate? So that means, what kind of version of PFAS is it? If it was typically, if the system is pre 2011 to 2014, that's probably going to be a C8 type of system, which means there's greater restrictions as opposed to C6. So the reason I would ask that question is, if you've got a system that was installed 3 years ago, and because of the plans for the facility, it's only going to be used for another 5 years, then if there's no restrictions, if you can contain the discharge of foam, then why change to SFFF? So each kind of scenario is very different. Can the PFAS foam after discharge be captured and processed? So this is what I mentioned earlier. What the concern is the discharge running into the environment. If we can capture 100% of that discharge due to stop valves and drainage, internal drainage tanks, then perhaps the PFAS-based foam is still good for its expected lifetime. I mentioned earlier about the sprinklers, and then this is a very, very tricky one, cleaning the system, because these PFAS molecules, they'll find their way into all surfaces. They're very good at clinging onto surfaces. So if you've got a pipework system that's got corrosion in it, you can flush that with water once, do it again twice, and your readings will go down. But will water alone clean the system sufficiently? Over time, if there's corrosion in the pipe, the PFAS comes back out. So you probably need to flush again. Now there's companies with different types of cleaning methods coming onto the market. It's quite an expensive process, but obviously it's better than cleaning with water alone. So again, it depends how clean you want the system. Does your system need to be a very low parts per billion due to environmental rules and regulations and laws inside your company, or do you just want to have as clean a system as you can? So that might help you decide, do I just flush with water or do I use a special cleaning process? And remember, the water that you flush with shouldn't go to drain. That should also be processed. So even flushing with water can still be an expensive process. Okay, so I think I'm 15 minutes before the deadline of time. I don't know, Ray, if there's any questions come in already during the chat.
No, there's been no questions so far.
Okay.
Um,
So if anybody wants to ask a question, we've got a little bit of time, I think, or questions can be sent to myself or Ray later.
So if you have any questions, feel free to unmute and ask. Yes, if you need a copy of the presentation slides, please send me an email to the Viking APAC at vikingcorp.com.
Okay, so I either went on too long and everybody left or wants to leave, or I covered everything that people wanted to know today.
Are there any questions, ladies and gentlemen, other than the request for the slides? Well, we don't have any questions at the moment, and I guess maybe some of you may need some time to digest the information. You have our email address, vikingapac@viking.com, or you could email any of our Viking colleagues in your territory, and they'll be sure to send the questions to myself and Simon, and we will make sure we answer those questions for you. All right. Without further ado, I just want to say thank you so much to Simon, and thank you all of you for attending our seminar today.
Yeah, thank you, everybody.
Thank you. Thank you.
Thank you.